Hello dear students, welcome back to Aja Physics. Today in this video we are discussing cross product or vector product. This is actually the ninth video on Maths for Physics video series. These videos will definitely help you to understand physics through mathematical language. Now let us understand cross product in a better way. Let us take two vectors, vector A and vector B. I will take vector A and vector B and join their tails as shown in the figure. Something like this. This is vector A and this is vector B. I am joining the tail of the two vectors. Let this theta be the angle between the two vectors. Now this vector A will be having two components. One component of vector A is along the vector B and this component is called as A cos theta. Similarly, there is a component of A perpendicular to vector B which can be called as A sin theta. Suppose if you are multiplying A sin theta with the magnitude of this B, this product is basically called as the cross product of two vectors A and B. This cross product of two vectors will always give us one more vector. So that you can always write A cross B, the cross product of two vectors, as one more vector C. And the C will be having magnitude AB sin theta or BA sin theta. Because this C is also one more vector, same as A and B, the C must also have certain directions. Now, as we have seen in the last video about dot product, the dot product measures the alignment or agreement of the two vectors in one particular direction, and it gives the scalar physical quantity. Similarly, this cross product measures perpendicularity of the two vectors because we are multiplying magnitude of one vector with the perpendicular component of the another vector to it. Say for example, we are multiplying this A sin theta with the magnitude of the B and we are getting cross product of the two vectors. In this video, we will understand how this cross product of two vectors graphically can be represented as well as how it can behave physically as well. Cross product of two vectors does not simply represent perpendicularity of the two vectors, but also it gives the orientation of the plane in which the two vectors are spanning in 3D. Let us understand that. I will take this vector A over here. I can take or I can shift this vector A anywhere in the plane of the board without changing the magnitude and the direction. Now I will join the vector B, tail of the vector B to the tail of the vector A, as usually this is the angle. Now I can construct a parallelogram in the plane where the two vectors A and B are spanning. I mean in the plane of this board only. By considering this A and B as the two adjacent sides of this parallelogram. So now this is a parallelogram constructed using these two vectors. Basically, the cross product of two vectors A cross B, which is nothing but AB sin theta or BA sin theta, gives area of this parallelogram. Direction of this area or direction of the parallelogram can be obtained by drawing perpendicular to this plane. That perpendicular is nothing but the resultant vector C, which is nothing but the resultant vector of cross product of the two vectors A and B. Basically, the length of this resultant vector, which is drawn perpendicular, which is nothing but a perpendicular to the plane of this parallelogram, gives us magnitude. That means the magnitude of C gives you AB sin theta or BA sin theta, and the direction will be shown by arrow mark. Let us understand what exactly the direction of that perpendicular to the plane, whether it is coming out of the board or getting into the plane of this board or plane where the parallelogram is constructed by using the simple rules. So now let us understand how to specify the direction of resultant of cross product of two vectors. Here I have taken one horizontal plane where the two vectors A and B are spanning. Now I will take the cross product A crossed with B. So to find out the direction of A cross B, what I will do is I will hold these fingers of my right hand in the direction of A, and the thumb will be the direction of the resultant vector of A cross B. So now let us understand this. These are the four fingers of my right hand holding in the direction of the vector A. And now to understand A cross B, I will curl these fingers towards this B. Okay, so this is how I am curling. This is what A cross B means. So therefore, A is spanning towards B, somewhat like this. By now it is at present it is having certain angle. The angle between A and B is theta, and now A cross B is somewhat like this. So therefore, as I said already, this is a horizontal plane. So the direction of A that is shown by the four fingers of my right hand, something like this, and B is somewhat like this, and I am curling A towards B, something like this. So the product A cross B, the cross product of A and B, A cross B, will be in the direction of the thumb. So the direction of the resultant of the cross product is exactly upwards in this diagram. Okay, so this is what vector C I can say. So vector C is nothing but A cross B. And let's come to the second diagram where this is also one of the horizontal plane, and in the same plane the same two vectors A and B are spanning. Now I am going to calculate not A cross B but B cross A, something like this. So this is how to calculate B cross A. Okay, so I am holding the direction of these four fingers in the direction of B. Okay, so this is how I'm holding these four fingers in the direction of B in the horizontal plane, and these four fingers are now curling, or they are bending towards this A. So somewhat like this. Okay, so therefore the resultant of B cross A is exactly downwards now. So this in this horizontal plane over here, the direction of the resultant of the cross product C is downward, and this can be written as minus C, because the direction of the resultant vector earlier when we are doing A cross B is upward, and the same vector we are getting but in the opposite direction, that is why it is minus C. So which can be called as B cross with A. Here we need to observe one thing, whether it is A cross B or B cross A, the magnitude of the resultant vector C is exactly same, which is nothing but what I am telling is magnitude of A cross B is exactly equal to the magnitude of B cross A, which is nothing but C only, which is nothing but the magnitude of vector C. But the direction of this vector C is exactly reversed when you are reversing the order of multiplication in the cross product as shown in the diagram. Now let us understand one more important thing here, that vector C, the resultant of the two vectors, is always perpendicular to both the vectors A and B. Okay, A and B are involving or they are participating in the cross product. They are in one particular plane, and the resultant vector is always coming out of that plane in a perpendicular way. Now let us understand some important properties of this cross product. So these are some of the important properties of cross product. You better take or pause this video and take note of all these properties. Now finally, let us understand if the two vectors are given in component wise. Say for example, vector A is having its three components in space, component along x-axis, component along y-axis, component of the same vector along z-axis. Similarly, vector B. If you want to take the cross product of these two vectors which are given in component form, we will take the determinant of this matrix. The first row of this matrix is nothing but the basis vector I, j, k. These are the basis vector because by using them we constructed A and B. We are expressing A and B. And in the second row, ax, ay, az components of A. In the third row, bx, by, bz, which are nothing but components of B. How to take the determinant? That is very simple. The determinant of this matrix, I will take this I cap first, and I will take the cross product over here. Say for example, ay, bz minus with the product of these two things, by and az. And this will be a number, and that will be having its value along the x-axis. That's why it is I cap. I cap is nothing but a unit vector along x-axis. So what we have done here is, by choosing the x component of the resultant vector of A cross B, so that's why I took this out of the bracket I cap, and I will eliminate the component of the two vectors which are in this column, and I will eliminate this row completely. So the remaining four numbers, I'm taking the, between them I'm taking the cross product. Okay, that's what is happening. Similarly, the next component I will take minus j, where j is the what do you call y component of the dot product of the two vectors A and B. So by eliminating these two, row and column, so I'm taking the cross product. Ax multiplied with by, ax multiplied with by, and similarly bx is multiplied with az. Oh, sorry, this is ax multiplied with bz, is it not? And minus of bx multiplied with az, bx multiplied with az. And lastly, so I will write here plus this k cap. So I am going to eliminate this column and this row, the remaining four, and I will take the cross product between them. Ax and by inside the bracket, ax multiplied with by, similarly bx multiplied with ay. So bx multiplied with ay. So this is how we will calculate the cross product of two vectors when they are given in component wise. So please like and comment your opinion, or if you have any doubts, please uh, put your doubts in the comment section. Thank you very much for watching.